Alright, in this video, find the area inside this cardioid and outside the circle r equals 6. I've already sketched everything because I'm assuming you're coming to this video with the intent of taking the BC exam, and it's very unlikely you'll have to sketch anything yourself. So, we have an area between polar curves question, and we know that the general approach is that the area is going to equal your outer minus your inner, and we're thinking of our outer as well, in this case it would be 4 plus 4 cosine theta, so 1/2, I'm going to leave off the limits of integration, 4 plus 4 cosine theta squared d theta, and inner would be similarly 1/2, and then 6 squared, which, if we want to do it in one integral, would just be 1/2 the integral from wherever to wherever, so what we really want to know is the limits of integration. Okay, that's what's going to make this problem take more time than just a few seconds here. So if you look at this graph here, what we really are interested in is, these angles here. So this angle here and this angle here, this is where, first of all, it's the boundaries of this purple area region that we're trying to find the area of. And I need to know what those angles are in order to compute this integral. And these angles are these angles that I'm looking for are where the two curves intersect. And they intersect when their r values are the same. And so what we want to do is find when these two r values are equal, and we're going to go to our Cartesian. So let me just note, we need theta 1 and theta 2. In other words, we need to solve. So we want to know when 4 plus 4 cosine theta is equal to 6. And not only that, there's actually an infinite number of solutions in polar to that equation. If we think about the range of values where we care about, this is negative, right? This angle here is negative 90 degrees, or negative pi over 2, and this is positive pi over 2. So really we just want the intersection on the interval negative pi over 2 to pi over 2. That could be done by hand, but that's not really the point here, so we'll just utilize our calculator. And we're going to go into Cartesian, and we're going to call this y1, and we're going to call this y2, and we're going to find where they intersect on the interval negative pi over 2 to pi over 2. Okay, that's my x window. And then, look up here for our y window. The furthest out, the biggest the r value, remember r is your dependent variable, so it will be y in Cartesian, is 8. So I'm going to make my my window, my y window, maybe like I don't know, negative 9 to 9. We'll see what that looks like. Okay, I guess I should call that r if I'm gonna. Okay, so let's go to our calculator. I've already put these each into y1 and y2. So let's go here. So in y1, I've got 4 plus 4 cosine x. I've got y equals 6. Let's go to our window here. I've put in negative pi over 2 for x min, pi over 2 for y min. I said what I was going to do is make this negative 9 to 9. Let's just do do that, and we hit graph. And we want to know where, right, those two intersection points are what we want. So second, calculate intersect. Again, that's what I get for not doing the paid version. I probably should do that soon. Alright, so I guess I'll find this first x value here, first curve. Sorry, I want to make sure I get the right function here. Intersect, left bound. So I think if you have a different calculator, it just has you do curve 1, curve 2. Mine's a little different. Okay, so they intersect at 1.0472. Just going to sketch this really briefly. Okay, so we got theta and r, and right from negative pi over 2 to pi over 2. Okay, so I have r equals 6, and then I have and then the curve 4 plus 4 cosine theta, it's just going to look like that. So right, it's going to go up with that. So we want these intersections. I just found that this is 1.042, I believe. 1.7. Now I'm going to guess that there's a symmetry here. Okay, but we can confirm that just by computing. It's symmetric. But if you're not confident with that reasoning, let's just go do it anyway. Okay, as we said, negative 1.0472. So we go to our blank screen. Okay, let's see if it stored it. Sometimes it stores my values. Oh, there we go. Nope, that's not quite it. It's not storing my values. So let's I'm just going to type 1.0472. That was the upper limit of integration. And I'm going to store that as b, since it's my upper limit of integration. And then I'm going to store negative 1.0472 as a. Okay, so STO B and 1.0472, oops, negative. Okay, store that as A. And now I'm going to integrate from A to B. You might, again, just note to yourself that you're storing these as A and B. And now we can continue this integral. Okay, so we'll do 1/2 the integral from A to B of, and I have this as y1, and this is y2, and we'll see what we get. Integral from A to B. I'm going to insert a 0.5 in here. Y1 squared.
Okay, today is June 1st. Please say your name and spell it.
I'm God, G-O-D.
Sorry, once again.
Okay, today is June 1st. Please say your name and spell it.
I'm God,
Right, and this should do it.
G-O-D.
You're getting 18.610 or 18.611. Both of those would be accepted on the AP exam. All right, so it's not the formula that's that big a deal. It's usually just finding the limits of integration using your calculator. And note that the strategy, as we did before in a previous video, is to go graph the Cartesian or rectangular versions of these polar equations, okay? It's not, you never want to be in polar because it's not easy or even possible to find intersections on TI-83s and 84s. All right, I hope this helped, and good luck.